Hey, can you lift a truck with your hands? No? Shocker. But let me introduce you to nature's original strongman, the ocean, which casually tossed 700-ton boulders around like they were pebbles during a mega-tsunami that hit Africa thousands of years ago. This wasn't just a bad day at the beach. This mega-tsunami was so powerful, it made the 2004 Indonesian and 2011 Japanese tsunamis look like kiddie pool splashes. Now, to give you an idea of how terrifying regular tsunamis already are, the Japan tsunami produced waves 133 feet tall. The Indian Ocean tsunami was slightly smaller, but it took over 200,000 lives across many countries. Now imagine something way worse. You see, for a long time, scientists thought waves that big were just science fiction. But then they found these enormous boulders, massive chunks of rock, flung far inland, and did the math. It turns out only waves around 800 feet tall could have pulled off that kind of rocky vandalism. And the culprit? A volcano that literally fell apart into the ocean and triggered one of the most powerful tsunamis Earth has ever seen. Usually, tsunamis are blamed on underwater earthquakes, tectonic plates getting into slap fights. But volcanoes? Oh, they've got tsunami potential too. In 1883, for example, a volcano in Indonesia named Krakatoa erupted for 6 months non-stop until it exploded, and the explosion was heard all the way in Australia. This triggered many tsunamis, some almost 100 feet tall. Still, that was more like a toe dip compared to the full cannonball from the mega-tsunami. Back in ancient times, the volcano that crumbled during the mega-tsunami was huge, and it didn't just fall apart. It lost a chunk that was 10 times the size of Mount Everest. 10 Mount Everests. It was like the Earth wanted to see what would happen if we threw a mountain into the ocean just for fun. It was so massive that when the entire side of the volcano belly flopped into the Atlantic, it created waves that could cover the Statue of Liberty 3 times. It also destroyed an island more than 30 miles away. The volcano behind this real-life Michael Bay scene was called Fogo, located on, you guessed it, Fogo Island. This island is basically just a whole single volcano that rose from the sea thanks to a magma hotspot, a place in the ocean where a lot of magma escapes and erupts like an underwater volcano. Over time, this magma cooled and stacked up like pancakes until, voila, after 7 major eruptions, the island popped out of the ocean like it was playing peekaboo. Surprise, it's a volcano. But Fogo's dramatic entrance was also a ticking time bomb. You see, the more a volcano grows, the heavier it gets, and if there's not enough magma inside it to support it, the whole thing can just collapse. Sometimes it doesn't take much. A minor earthquake, some erosion, or just a poor foundation made of soft sediment can trigger a collapse. It's like a really tall guy trying to balance over a bunch of marbles. Fogo had all the bad luck ingredients: too tall, too heavy, and built on squishy ground. And it gets worse. As the volcano grows heavier, it starts squishing the magma underneath. That lava can't rise, so it just simmers down there, slowly thickening like soup left on a burner for too long. Gases build up, pressure increases, and eventually, kaboom! It's the volcanic version of eating too many burritos and then trying to hold in a sneeze. This massive pressure and imbalance can trigger what's called a flank collapse, which is science speak for oops, half the volcano just fell into the ocean. That's what happened with Fogo. Most of the volcanic islands that form this way are long gone, but Fogo is still very much alive and kicking. In fact, it last erupted in 2014, and considering that it goes off every 20 years, maybe don't travel to Fogo Island in around 2034. For the longest time, scientists believe only big, bulky volcanic islands could collapse like this. But new research says that even smaller, skinnier guys, like the Danny DeVitos of the island world, aren't safe either. The thing is that small volcanic islands only seem stable because of their small mass. It's like Danny DeVito and Arnold Schwarzenegger both slipping on the ice. Arnie's fall might cause more chaos, but Danny can still go flying. And those little collapses? Yes, they matter. Take Santa Maria, a tiny island that's about 170 times smaller than Hawaii. It has collapsed multiple times, not because it wanted to, but because it's basically standing on soggy breadcrumbs. Its foundation is loose marine sediment, and to make things worse, it's sitting right next to the East Azores Fault, where 3 tectonic plates meet up for daily slap fights. This fault is responsible for many earthquakes and even some tsunamis that happened in Lisbon in the past, so you can imagine what it's like living right above it. Every time the volcano in Santa Maria erupts and grows, it also sinks. But when a chunk collapses, it bounces back up like a buoy. This seamount to island again roller coaster means that Santa Maria has popped in and out of the ocean like a submarine playing peekaboo, and with every peak comes a potential tsunami. Another volcano with similar trust issues is Pacaya, located in Guatemala. Between 2011 and 2013, scientists spotted strange movements in the soil, tiny shifts that suggested something underneath was getting restless. Sure enough, in 2014, Pacaya erupted. Luckily, it didn't collapse, but that risk still looms, especially if magma gets trapped in it like it did with Fogo. The consequences could be explosive, literally. In fact, about 1,000 years ago, Pacaya experienced a collapse that sent debris avalanches more than 15 miles away. Since then, it's rebuilt itself like a fiery phoenix, but it could still crumble again. That's why volcanologists obsess over the tiniest wobbles. It's not paranoia if the mountain really might fall. Now you might be thinking here, okay, but that was the past. Surely that kind of ridiculous mega-tsunami collapse can't happen again, right? Well, welcome to the 21st century. Islands like Hawaii, La Palma in Spain, and various parts of the Caribbean are sitting on the same kind of geological whoopee cushions. All it takes is the right combo: loose foundation, steep slopes, maybe some trapped magma, and boom, flank collapse. In fact, it's already happened recently. In 2018, Anak Krakatau, the volcanic baby of the infamous Krakatoa, lost a big chunk of itself during an eruption. It caused a tsunami, but it was more awkward than devastating, like a volcano losing its pants on stage. Embarrassing, but survivable. But that's just amateur hour compared to history's real showstoppers. Ritter Island's 1888 collapse was so intense that the island literally got shorter. It went from being more than 2,000 feet tall to a mere 460 feet. But the record holder is the legendary Latua Bay megasplash from 1958, where a 7.8 magnitude earthquake triggered a massive landslide that sent a wave taller than the Empire State Building roaring through Alaska at highway speeds. Strangely enough, only 5 people lost their lives here, but on the other hand, the destruction path it left behind can still be seen today, all the way from space. Melting glaciers and ice caps can make volcanoes collapse too. When they melt, there's a sudden decrease in pressure on Earth's crust that can destabilize entire volcanoes. It's called isostatic rebound. It's like suddenly yanking a chair out from under someone who's been sitting still for centuries. Whoops. Also, here's something you probably never thought you'd worry about on your island getaway. Some volcanic islands grow outward as lava pours into the sea, creating unstable platforms known as lava deltas. These deltas can collapse without warning, taking newly formed land, and sometimes tourists too, right back into the ocean. No pressure though, just thought, maybe you want to stay off steaming new land. So yeah, next time you're lounging on a beachy volcanic island thinking, wow, this place is paradise, just remember, it might also be a ticking geological time bomb with a flair for the dramatic. From ancient mountain-sized cannonballs to surprise lava deltas, volcanoes have a history of keeping things spicy. Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees. But at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit. But the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount. So all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink sea water. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams live long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps, each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet. An underwater earthquake opens a huge gap in the ocean floor. A large volume of water moves to fill the crack. At the same time, waves start to spread out from that point. They're just a foot high at first, but the closer they get to shore, the larger they become. When the waves reach shallow waters, they start to slow down. Their lower parts get to dry land first. This creates a vacuum effect that pulls the water away from the coast. The harbor and seafloor are visible now. And then, an enormous wall of water hits the shore. It wipes out everything in its path. Several minutes later, more waves usually arrive. Or it can be a landslide happening near a large body of water. Enormous amounts of forest, soil, and rock roll down into a lake or ocean, producing huge tsunami waves. Volcanic eruptions are responsible for 5% of the world's tsunamis. They can move great volumes of water and generate really big waves. Some tsunamis are caused by meteorites striking into our planet. If one of these red-hot space visitors strikes the ocean, The force of this collision displaces enough water to produce an extremely powerful tsunami. When a tsunami starts, its waves are usually just 1 foot high. That's what a small wave looks like. It comes up to the waist of the average person. Surfers call such rather big waves double overhead. The largest earthquake ever recorded happened near the coast of southern Chile. It triggered a tsunami that reached Hawaii, Japan, and the Philippines. The tsunami's largest wave was as tall as a 5-story building. The largest wave ever surfed was half as tall as the Arc de Triomphe in Paris. Garrett McNamara set this record in 2011 in Nazaré, Portugal. In 1995, scientists proved the existence of rogue waves, sudden unexpected swells. On that day, they saw an 84-foot wave. It was taller than the world's largest passenger plane Airbus A380. The giant was surrounded by smaller 20-foot waves. Tohoku tsunami waves in 2011 were generated by the strongest earthquake in Japan's recorded history. The highest wave was almost half as tall as the Brooklyn Bridge. Krakatoa's volcanic eruption in 1883 produced the loudest sound ever heard on the surface of the planet. The highest tsunami wave the eruption formed was as tall as the Statue of Liberty. April Fool's Day tsunami in 1946 was triggered by a powerful earthquake near Alaska. The tsunami's highest wave was a bit taller than the Colosseum in Rome. The Boxing Day tsunami started in the Indian Ocean in 2004. It was caused by a powerful undersea earthquake. Its tremors produced a series of tsunami waves. The largest of them almost reached the height of the Leaning Tower of Pisa. One of the most disastrous landslides hit Lodeland Valley in Norway in 1936. An enormous piece of rock, almost twice as large as the Eiffel Tower, broke loose and hurtled into Lofoten Lake. This caused an enormous tsunami wave. It was almost as tall as the Taj Mahal in India. 2017 Greenland mega-tsunami was triggered by a massive landslide at one of the fjords. The waves that flooded the shore reached the height of Big Ben. A powerful volcanic eruption caused a landslide from a 4,000-year-old lava dome. This set off Unzen volcano mega-tsunami. The largest wave was half as tall as the Space Needle in Seattle. Fogo mega-tsunami happened 73,000 years ago, when a part of the Fogo volcano collapsed into the sea. The mega-tsunami's largest wave was as tall as the Washington Monument. When the upper 1,500 feet of Mount St. Helens exploded, it caused a massive landslide. A part of this avalanche plunged down into Spirit Lake. This caused a wave that was more than half the height of the Eiffel Tower. The Vejont Dam mega-tsunami happened when a landslide dragged 9 billion cubic feet of forest, soil, and rock into the lake. A colossal wave overtopped the edge of the dam, taking out everything in its path. Its height was greater than that of the Golden Gate Bridge. A landslide in Lituya Bay in Alaska formed a megawave, one of the largest ever recorded. The mega-tsunami surged over the headland, washing away trees, plants, and soil down to bedrock. The wave reached more than half the height of the Burj Khalifa, the tallest construction in the world. A third of the East Molokai volcano in Hawaii caved in and collapsed into the Pacific Ocean. This created a tsunami the size of the second tallest building in the world, Shanghai Tower. If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupo volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupo as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes, like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animals' response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only 2 confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, It's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these two being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable, as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger. Did you know there's a guy who rode on a wave for 7.5 miles? It was accomplished by Brazilian surfer Picaruta Salazar in 2004. Just for comparison, Central Park in New York extends for a mere 2.5 miles. That was the Pororoca wave, and it can only be surfed for 3 days a year. It's pretty powerful, so it sort of pushes you. But there are definitely some tough spots where it's not that easy to catch waves. If you're looking for the gnarliest surf spot, Pipeline in Hawaii is where it's at. But beware, it's not for the faint of heart. This place is known for its massive waves that can reach up to 20 feet tall. And did we mention the shallow reef? Yeah, wipeouts here can result in some serious injuries, or worse, you might end up sleeping with a fish. The waves at Pipeline are also super unpredictable, so you never know what you're going to get. It's like a box of chocolates, except instead of chocolate, it's huge waves that could crush you like a bug. But hey, if you're feeling brave, the annual Billabong Pipe Masters competition is held there every winter. Just make sure to bring your A game and a change of underwear. Even the most experienced surfers approach Pipeline with caution and respect. It's like trying to tame a wild animal. One wrong move and you're toast, or dinner. So if you're ready to ride the gnarliest waves in the world, come on down to Pipeline. Just don't say we didn't warn you. For those who are dreaming California, there's a tough spot in the Golden State for you. Mavericks is notorious for its massive swells and strong currents. making it a challenge even for experienced surfers. Hold on tight, because this wave is gonna take you for a ride. First off, let's get one thing straight. Mavericks ain't for the weak. This bad boy can reach heights of up to 60 feet. But hey, if you're a seasoned surfer and you're feeling brave, then Mavericks is the place to be. Located just off the coast of Half Moon Bay, this spot is known for its massive swells and killer waves. It's like the Hulk of surf spots, big, bold, and ready to smash. Now, don't go thinking that Mavericks is all about the waves. Oh no, my friend. This spot is also home to some of the coolest surfers around. These dudes and dudettes live for the rush of catching a maverick wave, and they'll do whatever it takes to get out there. But here's the thing, Mavericks isn't just about surfing, it's also about community. These surfers have each other's backs, and they know that when they're out there on those massive waves, they're all in it together. It's like a big, salty family. So there you have it, folks, Mavericks, the wildest, most insane surf spot in California. If you're up for the challenge, grab your board and head on out. Just remember, when you're staring down a 60-foot wall of water, it's okay to scream like a little girl. We won't judge. Chupo in Tahiti also has some of the heaviest waves in the world, breaking over a shallow reef and creating intense barrel rides. First of all, the name itself is a mouthful. It's pronounced Chupo, and it means broken skulls in Tahitian. Yeah, you heard that right, broken skulls. The waves at Chupo are massive and can reach up to 23 feet high and break over a shallow reef, which creates a super powerful wave that can barrel for hundreds of yards. And if you wipe out, well, let's just say you'll be getting up close and personal with that reef. It's like a cheese grater for your skin. So make sure you bring some Band-Aids and a good insurance policy. But hey, if you're up for the challenge, Chupo is one of the most epic surf spots in the world. However, I hope you're going to choose a much safer spot. If you're looking for some cool waves but don't want to risk your life, then you gotta check out these safe surfing spots around the world. First up, we got Waikiki Beach in Hawaii. This spot is perfect for beginners and pros alike, with consistent waves and a sandy bottom. Plus, there are lifeguards on duty to keep an eye out for any trouble. Next, there's Bondi Beach in Australia. This iconic beach is known for its beautiful scenery and chill vibes, but it also has some great waves for surfing. The water is shallow, and there are plenty of surf schools around to teach you the ropes, or in this case, the boards. But if you're looking for something a little more exotic, head over to Nocera in Costa Rica. This spot has warm water, consistent waves, and a laid-back atmosphere. Plus, the locals are super friendly and will welcome you with open arms. Last but not least, there's Muizenberg Beach in South Africa. This spot has some of the most consistent waves in the world, but they're not too big or dangerous. Plus, there are shark spotters on duty to keep you safe from any unwanted attention from local carnivores. But no matter how safe the spot is, you're still going to need some cool life hacks to bring your surfing to a brand new level. Have you ever wondered why surfers use wax on their boards? Well, let me tell you, it's not just for show. See, when you're out there shredding the gnar, you don't want to slip and slide all over the place like a penguin on ice. That's where the wax comes in. Basically, the wax creates a grip on the board so you can stick to it like peanut butter on bread. Without it, but here's the thing, not all wax is created equal. You gotta find the right kind for your board and the water conditions. It's like choosing the right flavor of ice cream for your cone. You don't want to end up with mint chocolate chip when you really wanted Rocky Road. So, next time you see a surfer waxing up their board, just remember they're not doing it for the smell, although some waxes do smell pretty sweet. They're doing it so they don't wipe out and embarrass themselves in front of all the folks on the beach. And that's worth its weight in gold. And by the way, did you know that rubbing a little bit of wax on the bottom of your feet can give you a better grip on your board? Yeah, it's like magic. No more slipping and sliding around like a seal on a wet rock. Another common hack is to wear earplugs. You see, there's even a condition called surfer's ear. Surfers are constantly exposed to cold wind and water, and some of them even surf in cold temperatures. If your ears are constantly exposed to cold, your ear canal may shrivel up. As a consequence, water, wax, you, and even air all get trapped in your ear, which may lead to certain infections. So, to prevent water and cold air from getting trapped in their ears, pro surfers like to use earplugs. But even if you're just a newbie, you gotta use their tip. Oh, and here's another classic. If you're surfing in cold water and don't have a wetsuit hood, just rub some petroleum jelly on your ears to keep them warm. Hey, why do you think some surfers have clear nail polish on their emergency kits? It's not for their nails, but for their boards. So, if you're dealing with a stubborn ding in your board, grab some clear nail polish and fill in the crack. It'll keep water from seeping in and causing more damage. However, pros will say that nail polish is a terrible idea, and there are a lot of repair kits out there. Yeah, this one's up to you. So, there you have it, my fellow wave riders. Now go out there and shred those gnarly waves like the pro you are.
Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard, and we've barely scratched the surface. Also, did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up. But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? Because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote-controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more. But getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city. Except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. They don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seem like they might have been made by bacteria, but hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? Researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? Shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system. How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans, and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic. A tsunami can travel unnoticed in the deep waters at the speed of 500 miles per hour, crossing an ocean in less than a day. When it approaches land, a tsunami will slow to about 20 miles an hour and begin to grow in height. Most of these waves are less than 10 feet high when they hit land, but they can reach more than 100 feet high, about 2 times as tall as the Hollywood sign. When a tsunami comes ashore, areas less than 25 feet above sea level and within a mile of the sea are in the greatest danger. But sometimes, tsunamis can go 10 miles inland. If you're by the coast and feel a strong earthquake, especially one that lasts for more than 20 seconds, that could be a major red flag that a tsunami is on the way. Keep an eye out for sudden changes in the sea level. If the water suddenly recedes way further back than usual, exposing normally submerged areas, that's a sign that a tsunami might be on its way. Plus, if you hear a roaring sound coming from the ocean, like a freight train or a jet engine, that's another ominous sign. and pay attention to any unusual animal behavior. Animals have been known to sense danger before humans do, so if you see birds or marine life acting strangely, it's time to take notice. If you receive an official tsunami warning from authorities, whether through sirens, radio, TV, or mobile alerts, don't ignore it. Take immediate action. If you're in a tsunami-prone zone and experience an earthquake, don't even wait for official warnings. As soon as it's safe to move after the shaking stops, head to the nearest elevated area promptly to ensure your safety. Practice evacuation routes before a real disaster. You might have to follow this route at night and in terrible weather. If you know it well, you'll need to do less thinking in an emergency, which can be life-saving. Talk about tsunamis with all your family members. Everyone should know what to do to minimize fear and win some precious time. Don't store your important papers and valuables in low-lying areas. Floodwaters can go really high during a tsunami, so put your documents in waterproof containers on higher ground. After an earthquake, bridges and roads often get damaged or become blocked. Not to get trapped in a car in a potentially hazardous location, walk or run towards safety. Never go down to the shore to watch for a tsunami. If you can see the wave, it means you're too close to outrun it. Most tsunami-prone areas have signs indicating evacuation routes. Look out for white and blue signs marked Tsunami Evacuation Route, or similar instructions to guide you inland and away from danger zones. In urgent situations where evacuation isn't possible, seek refuge on the third floor or higher in a sturdy building. Even better, aim to reach the rooftop of the tallest and most robust structure nearby. It's better than being exposed. A tsunami is not a single wave, but a series of waves with massive amounts of water that can flood for hours. The first wave may not even be the largest. So, remain on high ground, away from the coast until you receive an all clear from the authorities. You're really unlikely to survive a tsunami in a basement below ground level. As it passes over, everything in its wake gets submerged temporarily until the water recedes back to the sea. If you're in a basement during a tsunami, you might get crushed by collapsing buildings or swirling debris. Unless the basement is exceptionally sturdy, waterproof, and equipped with sufficient air supply, it's not a safe option for shelter. If you happen to be out at sea when a tsunami warning is issued for your area, stay put and avoid returning to port immediately. Tsunamis can sneak up on you with rapid water level changes and dangerous currents in harbors and ports, making them unsafe. In large harbors and ports, authorities take charge during tsunami alerts and direct vessel movements for safety. It's important to stay in touch with these authorities and follow any instructions they give regarding moving your vessel. For smaller ports without such organized control, it's a better idea to carefully relocate your boat to deeper waters. If you have a small boat, the best you can do is leave your vessel at the pier and seek higher ground yourself. If a tsunami gets you in the water, find something sturdy like a tree, a door, or a life raft. Grab onto it tightly while you get carried by the waves. Try your best not to swallow any of the water. Tsunamis can pick up chemicals and waste, which won't do you any good. People in life jackets have a higher chance of survival because they will remain on the surface of tsunami waves and can breathe normally. Tsunami waves aren't like ordinary waves, so they aren't suitable for surfing. Tsunamis don't have a face to ride. They're more similar to tides as they rush in and out. They're much larger, faster, and more powerful. So, trying to surf them is not only dangerous but also illegal in many countries. Because tsunamis come from underwater disturbances, like earthquakes, they're even dangerous for submarines. Despite submarines' robust design to withstand underwater pressure, the force of tsunamis can cause damage. Tsunamis also generate strong currents that can mess up a submarine's ability to navigate effectively. In cases of severe tsunamis, submarines may get hull damage, threatening their buoyancy and integrity. Such scenarios can lead to submarines sinking or being carried away by the waves. That's why submarines operating in tsunami-prone areas must be extra careful and equipped to respond swiftly if this sea monster strikes. Scientists still can't predict tsunamis, but they can use their expertise in seismology and historical tsunami data to identify earthquakes likely to trigger tsunamis and issue warnings. They gather crucial data from seismic and water level networks worldwide, which enables them to swiftly assess earthquake characteristics such as magnitude, location, and depth. Utilizing this information, they determine whether an earthquake has the potential to generate a tsunami and decide on issuing tsunami advisories. For regions like the US and Canada, warning center scientists can typically issue preliminary messages within 5 minutes of an earthquake. These messages include alert levels, earthquake details, threat evaluations, anticipated wave arrival times, recommended actions, and potential impacts. On the 26th of December 2004, early in the morning, an enormous earthquake shook up the ocean floor near the Indonesian island of Sumatra. This seismic event unleashed a monstrous series of waves, tsunamis, that spread out across the Indian Ocean, reaching as far as East Africa over the next 7 hours. These waves were towering walls of water, some reaching a height of over 30 feet. When they slammed into the coastlines of countries like Indonesia, Sri Lanka, India, Maldives, and Thailand, the devastation was catastrophic. Over 200,000 people lost their lives in this most devastating tsunami on record. And it wasn't just the immediate impact. Long-term consequences hit hard too. Villages, resorts, farmlands, and fishing areas were destroyed or submerged in salt water along with debris. Japan is one of the most earthquake-prone countries in the world because it's located on top of 4 converging tectonic plates that constantly interact with each other. After a terrible tsunami in 2011, the country started a colossal project dubbed the Great Wall of Japan. With a jaw-dropping price tag of around $13 billion, this wall goes from the north to the south of the country. The goal is to safeguard coastal towns from future tsunamis, buying its people precious time to save themselves. Some locals worry that this towering structure will sever their deep-rooted ties with the sea. They fear losing touch with the ocean's rhythms and cues, which are crucial for spotting upcoming disasters. But for many coastal towns, the wall is a lifeline, giving them hope for rebuilding shattered lives post-disaster.
You have friends over for dinner. You set your drink on the counter and go help your friend set out some desserts. When you get back, you notice the liquid in your cup. It's sloshing around and the ice cubes look like ships on a rough sea. Now you feel it too. On the ceiling, the chandelier is swinging like mad. Then you hear someone scream, "Earthquake!" The house and everything in it is rocking back and forth. You try to run for cover, but the shaking keeps you stuck in place, fighting to keep your balance. The cabinets look possessed, and glasses and dishes fly out and smash on the floor. The bookshelves topple over, and everything hanging on the walls sways and falls off. You duck under the dining room table, trying not to get hurt on all those broken dishes. Yeah, you've been through earthquakes before, but none like this. Checking your phone? Typical, no signal. You can't believe what's about to happen. The screams get louder, and suddenly the whole house collapses. The biggest earthquake ever recorded happened in Chile in 1960. Disaster came in the afternoon, just when everyone was out enjoying themselves. To cause serious, life-changing damage, you need to have a magnitude of around 7 or so on the Richter scale. This one was 9.5. This part of Chile is smack dab on the so-called Ring of Fire, the most active volcanic and seismic area in the world along the Pacific Rim. The initial shaking lasted around 10 minutes, and after 2 days, many aftershocks were still strong enough to set off a volcano in the south of the country. But that's not where it ended. The earthquake unleashed a series of tidal waves all over the Pacific Ocean, with some reaching over 80 feet high. The waves and earthquake were so strong that they even affected Hawaii, Japan, and the Philippines. It caused around $500 million $1960 worth of damage. Many were left homeless. Much of their infrastructure was smashed too. Buildings as far as the eye could see were toppled, and debris piled everywhere. Scientists estimate that this earthquake was so powerful it shifted the Earth's axis, making our days 1.26 microseconds shorter. That might not seem like a lot, but think about it. Just one natural disaster was strong enough to make time move. Many of the coastal cities were flattened and floods were widespread. The economy spiraled downward. According to studies, if this earthquake happened today, it caused more than $20 billion in damages. So, what would happen if an earthquake twice that size hit without warning? For starters, you'd likely feel the effects even further away. Tidal waves wouldn't just hit the coasts of Japan and the Philippines. They would move even further to China, Korea, Vietnam, and even Australia. And those waves would be significantly higher than 80 feet, perhaps double that. That's like 8 giraffes piled on top of each other, surfing your way. If you lived by the coast, you'd notice the waves. If you saw the water recede way back so you could practically see where all the fish call home, you'd know it was time to run. Chances are that a tsunami's heading your way. Say it really happens. You're caught under the wreckage, not knowing what's going on. You manage to free yourself and escape to the fresh air. And you're not alone, because all the houses in the neighborhood have turned into piles of bricks and rubble. The bridges have also collapsed, leaving people stranded on either side. You look around, dust yourself off, and rush to find help. Fire trucks and ambulances drive between the broken-down cars and rubble. You try to make it to your car, but the aftershocks are still hitting, and you're getting tossed to the sidewalk. With all the cell towers down, you can't call anyone on your phone. Your knees are shaking, but you manage to power through. Once you reach your car, you see it crushed under a boulder, like a giant soda can. You continue on foot and eventually reach downtown. It looks as if some giant got angry and knocked all the buildings down. You push forward and try to see if you can find some help. Without warning, your phone vibrates. You check it and see 1,000 notifications about a 20-magnitude earthquake. You're still shaking, but that's all you. The ground is still for now. Uh-oh. You hear something in the distance, racing towards you. To your right, you see tidal waves as tall as buildings charging at you. Still in shock, not knowing what to do, you now come to your senses and run. You don't even know which way to go. There's a tsunami right behind you, and in front of you are broken down buildings with rocks and concrete still falling everywhere. Wait, there's a building that's somehow still standing. You need to get on top of that thing. You reach the elevator, but it's jammed. Not surprising. You bolt up the stairs as fast as you can, tripping on broken glass and plaster, but always managing to get back up. You look out a window and see the water. It's so close. You're nearly at the top. A few more flights and whoosh. The water forces its way into the building and drags you down at least 2 floors. You can barely see anything. Still, you know you must swim up. But the water keeps forcing you downwards. After about 30 seconds, you manage to swim your way out and continue climbing to the top. You scramble to the top floor and collapse on the roof. You're safe for now. The tidal wave is still going strong, plowing its way through the ravaged city center. Your phone is now waterlogged and useless. You have a perfect 360-degree view of your town covered in water and debris. The ground starts to shake again. Maybe you'll just sit around until this is all over, waiting for the rescue helicopter. But then, a loud explosion that almost breaks your eardrums shakes the ground even more. Off in the distance, smoke is rising, and soon it covers the entire sky. Darkness hides the morning sun. That's when you can see lava shooting up into the air and landing nearby. The lava forms into a river, flowing its way into town block by block. With this much seismic movement and the high intensity of the earthquake, the world's tectonic plates have shifted so that magma is pushing its way to the surface. From the earth, steam begins to vent. Then the heat hits you. You see the magma cover the ground like a blanket, eating up every car in its way. What's worse is that the magma is melting the foundations of the buildings that managed to withstand the earthquake and the tsunami. The buildings in the distance are now sinking and collapsing into the raging lava pool that's replaced your town. One by one, every building descends. That means, the building where you're standing is also swaying. It's about to fail. That's when you see the light. You look up and see a helicopter above in the distance. You wave your arms, run around, jump, anything to get noticed. And it works. The chopper makes a few circles and finally drops you a rope ladder. As you're lifted in the chopper, you take a good look at the world below you as it wriggles around like noodles in a strainer. You land a few miles out and are immediately treated by a doctor in an emergency triage center. You were one of the lucky ones. A year later, the tsunami water has receded. The lava that flowed inland has cooled, but all that magma permanently changed the ground below it, and the whole town is gone. The disaster has thrown the entire country into a financial nightmare that'll last decades. It takes months to survey the town, making sure there's no dangerous electrical wires or busted gas pipes anywhere. They're rebuilding your town farther inland from where the old one was. In other towns, they rebuild directly over the ruins. In others, they just decide to move everyone to a nearby city. So, a mysterious discovery was made deep in the Red Sea, the so-called death pools. Woo, that's scary. In 2020, researchers embarked on a dive into the Red Sea. The mission spot was in the Gulf of Aqaba, between Saudi Arabia and Egypt. Near the end of their expedition, as they ventured deeper into the darkening waters, they noticed some strange seaweed floating above the seafloor. They decided to use a remotely operated vehicle and investigate it. Suddenly, they discovered these strange, motionless lakes of water within the sea. These are called brine pools. They're basically pockets of salty water deep on the ocean floor. And when I say salty, I mean it. Sometimes they're up to 8 times saltier than the ocean water itself. Mysteriously, they don't mix well with the surroundings. They formed millions of years ago, sometime during the Miocene epoch, back when weird creatures roamed the earth, like me, and deeply buried mineral deposits dissolved into the water. The largest pool spans about 170,000 square feet. Meanwhile, 3 smaller ones are under 107 square feet each. At first, this discovery didn't seem that scary. But here's why they're so horrifying. Not only are they disgustingly salty, they also lack oxygen. Now hold on a sec, isn't that normal for something that's underwater? Well, it turns out the Earth's waters are full of oxygen, and at least half of this element on our planet comes from the oceans. Just like plants on land, marine plants such as phytoplankton, seaweed, and algae munch on sunlight and produce oxygen through photosynthesis. They release lots of it into the surroundings. Marine life then eats half of it, so only about a quarter of the oxygen that we breathe actually comes from the oceans. Just like us, sea creatures need this element to survive. Without it, they can't breathe and support their metabolism to live. That's why these pools are super dangerous for most of them. It's like a puddle of thick syrup for bugs. When they get in, the poor things immediately suffocate and pass away. Which is why the pools are surrounded by a graveyard of marine animals. But let's see how these things can exist in the first place. Have you ever tried making ice cubes from salty water? Spoiler, it's pretty hard. When you add salt, the water gets harder than usual to freeze, a phenomenon that has a funny name, freezing point depression. Oh, that's because salt interferes with the hydrogen bonds between water molecules. As it finally freezes, stuff like particles, dirt, or dissolved salts get pushed out to the sides. As a result, the salt's kind of squeezed out of the ice crystals and gets trapped near the edges in small bubbles or pockets. Something similar happens in the ocean when seawater starts freezing under super cold polar caps. The salt doesn't freeze with the water. Instead, it gets pushed out, forming a super salty cold liquid, the brine. And then it sinks down to the ocean floor. On a large scale, all this process also helps currents to form. Despite being so dangerous, the pools are still full of microbial life, because microbes couldn't care less, they'll survive anywhere. There are literally thick mats of them in the brines. There are also some salt-loving creatures, like shrimps and eels, hovering around the pool's edges. They're being super creepy, waiting to catch unsuspecting prey that ventures too close to the toxic death pool. Ew. Well, it sounds icky, I know. But this discovery gives us some fascinating insights into how life might have originated on Earth. We already know from the evolution theory that we came from the ocean, but now scientists think that life might have begun in the deep sea in some super dark, oxygen-free places. These brine pools are like time capsules. They're one of the closest things we found to the early Earth. They can tell us the planet's history of earthquakes, floods, tsunamis, and more. For example, they have some traces of rainfall that happened over 1,000 years ago. And they can also help us search for life on other water-rich planets. For example, Mars most likely used to have huge oceans on it. Now, NASA scientists want to send a special instrument called HABIT for a special red planet mission to study things similar to our brine pools. This will tell us more about how life appears and survives in the universe. There is lots of unexplored fascinating stuff like this in the Red Sea. That's why scientists conducted the so-called Decade Expedition and spent around 5 months exploring the place. This expedition was launched by the National Center for Wildlife. They made so many remarkable discoveries that now we've got 77 new research papers. For example, they found over 10 blue holes, incredible underwater sinkholes that host unique ecosystems. They also learned that dolphins can use those blue holes to protect their young from predators. Scientists also found traces of great white sharks, a creepy community of deep-sea lanternfish living in low oxygen conditions, and even a new coral species. It's the most resilient deep-sea corals that also vibe just fine without oxygen, like microbes we mentioned. Speaking of which, research also showed us some new ancient thermal vents and large blobs of microbial formations near Farasand Island. Now, can you believe that with all that, we only explored 5% of the ocean? It's divided into several layers based on depth. Each layer becomes darker and more isolated from sunlight as we go deeper. The places that no sunlight can reach are terrifying. Now, the fun, cute layer with dolphins and turtles is called the epipelagic or sunlight zone. It's so tiny, but even this layer is about 650 feet deep. Then we have the mesopelagic or twilight zone. It's the layer of mysterious octopus, shark, and other loners, which extend to about 3,000 feet down. And then the horrors begin after this one. We encounter the bathypelagic or midnight zone. It extends to 13,000 feet below the surface, about a half of Everest above you. Here we have the famous poor blobfish, squids, and anglerfish. Below it is the abyssal zone. It extends to about 20,000 feet deep. Since there's not much sunlight or oxygen, as we mentioned, most creatures here are quite small, like tube worms and shrimp. The darkness continues until we arrive at the scariest place of the planet, the place full of trenches formed by tectonic plate movements, the Hadal Zone. It's named after Hades, the deity of the underworld in Greek mythology. Just like Hades' realm is dark, remote, and guarded, the Hadal Zone is the deepest and most depressing part of the ocean. It starts at depths of around 20,000 feet and can go down to 36,000 feet and more. The famous Mariana Trench also belongs to this zone. Only 3 people in history have ever explored these depths in person, making it one of the least explored and most mysterious places on our planet. However, despite crazy high pressure, near freezing temperatures, and complete darkness, there are still things who manage to survive here. Guys like amphipods, which are critters who feed on dead material sinking from above, and the Hadal snailfish, which lives as deep as 27,000 feet. So scientists used to assume that if there's no sunlight, there wouldn't be that much oxygen around. But one day, a research team decided to measure the levels of oxygen in one of those deep zones. Surprisingly, the levels were super high. They checked the equipment thinking that it was malfunctioning, but nope, all the sensors showed the same thing. Turns out the oxygen was somehow generated by rocks. These small potato-sized rocks on the seafloor are called polymetallic nodules. They're rich in metals like copper, nickel, and cobalt, and they're basically like small batteries. When you put a battery in salt water, it can produce bubbles of gas, a process called electrolysis. In the same way, these rocks create tiny electric currents, which are powerful enough to produce the same gases, splitting water molecules into hydrogen and oxygen. It's the first time we saw oxygen being produced by some non-living minerals. This is what scientists now call dark oxygen. It turned out that about half of large marine species, or megafauna, were living just on dark oxygen alone. All these discoveries are reshaping our understanding of where and how life could evolve. It means that we might be able to find life on other planets or satellites with low oxygen conditions, like Enceladus and Europa, the moons of Jupiter and Saturn, and they have large bodies of frozen water on them. Wow! The Boxing Day Tsunami, Indonesia. An undersea earthquake starts in the morning. Its tremors cause a series of tsunami waves. The largest reaches the height of the Arc de Triomphe in Paris. Unzen volcano, mega-tsunami. A powerful volcanic eruption triggers a landslide from a 4,000-year-old lava dome. It sweeps through the city of Shimabara and reaches the sea, setting off a mega-tsunami. The Vajont Dam mega-tsunami, Italy. A landslide drags 9 billion cubic feet of forest, soil, and rock into the lake. A dark wall of water covers the sky over a tiny village at the bottom of the Vajont Dam. Then, with a deafening roar, the wave overtops the edge of the dam, taking out everything in its path. Mount St. Helens mega-tsunami, USA. As the volcano erupts, the upper 1,500 feet of Mount St. Helens collapses into a massive landslide. Part of this avalanche plunges down into nearby Spirit Lake, which splashes the lake waters into a series of waves almost as tall as the Eiffel Tower. Alaska's Lituya Bay tsunami. A landslide caused by an earthquake creates a mega-wave. It surges over the headland and washes away trees, plants, and soil down to bedrock. Molokai, Hawaii. A third of the East Molokai volcano caves in and collapses into the Pacific Ocean. This causes a tsunami the size of the second tallest building in the world, Shanghai Tower. The waves reach Mexico and California. The Yucatan asteroid tsunami. The asteroid, which is rumored to have wiped out dinosaurs, strikes the Yucatan Peninsula. It creates a mega-tsunami, the largest in Earth's history. The first wave's almost twice bigger than the world's tallest building, the Burj Khalifa. Hurricane Mitch. Mitch forms in the western Caribbean Sea. Soon it strengthens to become the 8th most powerful Atlantic hurricane ever. The storm pours 4 inches of rain per hour for 2 days in Honduras. It causes terrible mudslides and floods. Hurricane Allen. Rare and extremely powerful, the storm is one of the few to reach Category 5, the highest possible. It causes more than $2 billion in damage. The Great Hurricane. After tearing down Barbados, the storm moves on. It strips the bark off the trees growing on Martinique and St. Lucia and travels further. This horrific natural disaster lasts for 6 days. Hurricane Dorian. It's the most powerful tropical cyclone to hit the Bahamas. The hurricane flattens most of the structures on the islands and sweeps them into the sea. Hurricane Wilma. The storm occurs in the Caribbean Sea near Jamaica and heads to the west. 2 days later, it gathers enough power to turn into the most intense hurricane ever recorded in the Atlantic Ocean. Hurricane Patricia. A regular storm develops a well-defined eye and turns into a Category 5 hurricane within a mere 24 hours. At one point, it travels faster than a Ferrari moving at its top speed. It makes Patricia the world's most intense tropical cyclone ever recorded. Kamchatka earthquake. It happens in the early morning 80 miles away from the shores of Kamchatka. The earth tremors produce a tsunami. The first 2 waves are catastrophic, up to 60 feet high. The third one's much weaker. Valparaiso earthquake, Chile. It happens at about 5 a.m. along the boundary of 2 tectonic plates. The tsunami, triggered by the earthquake, wipes out 620 miles of Chile's coastline. Tohoku earthquake, Japan. The first earth tremors start at a great underwater depth. The earthquake is so strong it moves Japan's main island. It shifts the planet on its axis by up to 10 inches and increases its rotation speed. The disaster also triggers a tsunami with 133-foot high waves that travel 6 miles inland. Indian Ocean earthquake, Sumatra. A rupture along two tectonic plates sets off an undersea earthquake. It begins at about 8 a.m. near northern Sumatra, Indonesia. It makes the planet vibrate nearly a half inch and sets off earthquakes all over the world up to Alaska. Good Friday earthquake, Alaska. The most powerful earthquake recorded in North America lasts for 4 minutes and 38 seconds. A 600-mile-long crack causes terrible landslides and a 27-foot tsunami. Areas 200 miles away get raised by 30 feet. Other places permanently drop 8 feet. Valdivia, Chile. The Great Chilean Earthquake starts in the afternoon and lasts for no less than 10 minutes. The disaster affects an area the size of California. It triggers tsunamis that reach the shore of Hawaii, Japan, the Philippines, Australia, and New Zealand. The average tornado usually lasts less than 10 minutes, but there are exceptions. El Reno tornado. It's considered the world's largest tornado based on width. At its peak, the twister reaches 2.5 miles across. The Perryville tornado, U.S. It occurs at about 2 a.m. and starts with snapping hardwood trees and breaking down stone constructions. Then the whirlwind becomes stronger. It levels two-story buildings, flips and tosses cars as if they were toys. Bridge Creek Moore tornado. When the twister gets into the town of Bridge Creek, its width is at its peak, 1 to 1.5 miles. The wind speed of the tornado reaches more than 300 miles per hour. This natural disaster causes $1 billion in damage. Manitoba, Canada. An outstanding tornado rages for nearly 3 hours. It breaks tons of trees and utility poles, damages roads and farmhouses, but miraculously misses every town on its path. Tri-state tornado, U.S. The world's longest-lasting single tornado travels 220 miles through Missouri, Illinois, and Indiana. The average tornado's path is usually no longer than 5 miles. Tupelo, Gainesville, U.S. An outbreak that consists of at least 12 single tornadoes wipes out everything on its way. The accompanying rainstorms also trigger severe flash floods that make matters even worse. Valjean landslide, Italy. At 10 p.m., a landslide with a volume of 100 Great Pyramids of Giza breaks off from the top of Monte Toc. It falls into the Valjean Dam reservoir, producing a tsunami wave taller than the Golden Gate Bridge. Yunnan, China. An avalanche of rocks, stones, and mud, so big it could fill up Sydney Harbor, forms a dam on the Jinsha River. The Hida River, Japan. Triggered by a rainstorm, 300,000 Olympic swimming pools of debris flows down before getting stopped by another, earlier landslide. Along the way, the landslide sweeps 2 buses off the road. Peru. A rock slide dams the Rio Montanero, a long river running through the center of Peru. The whole process takes no more than 3 minutes, which means the landslide moves at a speed of up to 87 miles per hour. It also leaves a trail of debris 5 miles long. The Usoy Dam, Tajikistan. Set off by a magnitude 7.4 earthquake, the rockslide falls into the Murghab River and blocks its flow. That's how the Usoy Dam, one of the tallest in the world, appears. Mount St. Helens, USA. At 8:30 a.m., after much buildup, a volcanic vent finally gives way and sets off a catastrophic eruption, which makes the entire north side of Mount St. Helens fall away. It's the world's largest recorded landslide. North Bonneville, U.S. In the middle of the 15th century, a great earthquake occurs. An incredible amount of debris rushes down from Table Mountain. It covers more than 5 square miles and blocks the Columbia River with a dam 200 feet high and 3.5 miles long.
Let me take you to a place that seems to be out of this world. Life inside this cave has been isolated from the outside world for about 5.5 million years. And it does show. See for yourself. due to such a long isolation, the conditions inside the Mobile Cave are like nowhere else on our planet. A unique ecosystem is flourishing there, even though there is a severe lack of sunlight inside the cave, and the air is toxic. The cave, located a few miles west of the Black Sea in Romania, was first discovered in 1986. Nowadays, you can only visit it if you have special permission. Plus, the central caverns are guarded naturally by narrow limestone tunnels and vertical shafts. So, if you're no stranger to claustrophobia, you'd probably better not enter this place. In the depth of the cave, the air has twice less oxygen than the air outside. Instead, it contains a lot of carbon dioxide and hydrogen sulfide, so not the freshest air you can breathe. It's also pitch black inside the cavern. But despite, or should I say thanks to, this cocktail of extremely harsh conditions, the site is a true goldmine for biologists. Shockingly, life seems to be booming here. In a 1996 study, scientists identified 48 species, and 33 of them were unique to the cave. Most of the creatures inhabiting the cave are tiny, with long limbs and antennae that help them navigate in the dark. They have no vision and lack pigment, and it makes sense. Why would you need to be able to see if you live in total darkness? And why would you need to be pretty and colorful with no one to see you? Now, I'm going to take you to another cave. It's no less amazing, but looks very different. This is the Giant Crystal Cave, aka the Cave of the Crystals, in Mexico. These ginormous crystals were found in 2000 by a mining company after the water was pumped out of the cave. Two miners then saw the crystals after entering the drying cave on foot. These awe-inspiring crystals are actually massive gypsum pillars hidden 984 feet underground. They're anchored to the walls and the floor of the scorching hot cave. Scientists estimate that the crystals could have been already growing for 500,000 years. That's why many of them are so long and wide that you can walk across them. Unfortunately, visiting this wonder of nature is impossible at the moment. But maybe it's for the better, since the Giant Crystal Cave is a dangerous place that can easily turn into a trap. For tens of thousands of years, it was filled with groundwater, which was originally pushed upward into the opening by a magma chamber located in the depths of our planet. The magma under the cave kept the water hot, but eventually the temperature of the water dipped below 136 degrees Fahrenheit. As a result, the water started to fill with calcium and sulfate, whose particles began to recombine into gypsum. And then, white-tinted crystals took over the cave. And since they stayed underwater, they were able to keep growing. You don't have to fly to space to take a closer look at a black hole. Scientists have found something very similar to black holes in the southern Atlantic Ocean. A black hole has such an enormous gravitational pull that once something gets pulled inside, it doesn't have any chance to escape. Even light can't get out of a black hole. But ocean black holes seem to be almost as powerful as their space relatives. But instead of catching the light, they do the same with water. Ocean eddies are massive whirlpools that spin against the main current. They usually swirl billions of tons of water, and most of them are larger than a city. These whirlpools are so powerful that nothing trapped by them can escape. But the scariest thing is that you might not even notice heading into one of them. These things are so huge that you won't spot their boundaries until it's too late. When scientists started exploring ocean vortices with the help of satellites, they discovered the borders of several eddies. After that, they managed to prove that, mathematically, these whirlpools are the same as mysterious black holes in space. Massive eddies are surrounded by super-tight barriers where fluid moves in closed loops. Even water can't get out from the inside of these loops. That's why tight ocean vortices play the role of enormous containers. Water inside them can be totally different from the ocean surrounding an eddy. And I'm not only talking about its temperature. The salt content inside and outside a whirlpool often differs as well. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Look at these underwater crop circles. For the first time, they were spotted in 1995, close to southern Japan's coast. Local divers called these 7 feet wide structures mystery circles. The enigma had been plaguing many minds for almost 16 years until the culprit was finally caught. Imagine the researchers' surprise when it turned out to be a male pufferfish. The fish needs a bit more than a week to build one circle, and the aesthetics are obviously crucial. A male is swimming inside the circle, digging valleys in the sand with its fins. But that's not all. The fish also use shells and corals to decorate particular parts of their circles. This whole build-a-circle thing has a practical purpose as well. The way a male fish swims pushes the sand toward the center of the circle and creates a mound which later serves as a nest. The next mystery on our list is in the Caribbean. Just off the coast of Belize, there's a giant sinkhole. That's the Great Blue Hole. It's about 1,000 feet across and more than 400 feet deep. Once, a long time ago, this hole was a cave. But then rising waters filled it, making it collapse in on itself. The deeper you'll descend into the Great Hole's crystalline waters, the darker it will become. You'll see tons of stalactite-filled caves there, but entering them is extremely dangerous, unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you'll notice that the water is shimmering. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. You might want to turn back right now. Who knows what you might come across in the murky depths. There was an old Amazonian legend that told about the river that was so hot that it boiled. And it was believed to be just a legend until Peruvian geoscientist Andres Russo questioned if the river could be real. All experts denied such a possibility. After all, hot rivers do exist, but only in the areas where there are volcanoes. As for the part of the country mentioned in the legend, there are no volcanoes in that region. But Andres Russo was too dedicated to give up. And in 2011, he finally located the river from the legends. The water in it was indeed steaming hot. Its temperature was 186 degrees Fahrenheit, not boiling, but pretty close to this point. But what shocked the researcher the most was the size of the river. One could think that the almost boiling water was the result of the activity of an underwater hot spring. But thermal pools are always small, while the river is 20 feet deep and flows for almost 4 miles. This is the only river of its kind on our planet.
When it's born, it's just a foot high, but the closer it gets to the shore, the larger it grows. Soon, it enters shallow waters and starts to slow down. Down there, humans, tiny like ants, scream and scatter in different directions. The first tsunami wave crashes into the shore. Its top moves faster than the bottom. That's what makes the wave so high and steep. The lowest point of the wave gets to dry land first. In the process, it creates a vacuum effect, which pulls the water away from the coast, burying the harbor and sea floor. Those who recognize this first sign of an approaching tsunami still have the chance to save their lives. 5 minutes later, and an enormous wall of water hits the shore and wipes out everything in its way. But it's not just a single wave, there are many. This phenomenon is called a wave train. How fast this train is traveling depends not on how far it is from the source of the waves, but on the ocean depth. Tsunamis can move as fast as a jet plane in the middle of the ocean, but once they enter shallow waters, their speed drops. It's very different when we talk about a tsunami's height. On the surface of the open ocean, it's often no higher than 1 foot. That's why even experienced sailors may not notice such unassuming waves. But the sea rises dramatically once the tsunami nears the shore. The first tsunami wave isn't usually the strongest, but lots of people don't know it and make a grave mistake that sometimes costs them their lives. After the first wave is gone, they relax and believe the danger is over. That's why the next waves, much bigger and more powerful, catch them off guard. The scariest thing about tsunamis is that they can travel across entire oceans with almost no energy loss. A tsunami can travel thousands of feet inland, It's usually so much water that its enormous weight and force sweep away everything in its path. Cars, trees, people, and even buildings. The roar of an approaching tsunami is louder than a jet taking off. Sometimes, a tsunami comes as a torrent of foaming water. At other times, it makes the sea withdraw, leaving behind stranded fish and overturned boats. But what can cause a tsunami, one of the most merciless and devastating natural disasters? In more than 70% of cases, it's an underwater earthquake. For example, the Boxing Day tsunami, which occurred in 2004 in Indonesia, was triggered by an undersea earthquake. The tremors produced several massive waves. The largest of them was as tall as the Arc de Triomphe in Paris. A landslide can also cause a monster of a tsunami, as it happened in 1963 in Italy. Then, more than 9 billion cubic feet of forest, soil, and rock rolled down into a lake. A dark wall of water covered the sky over a tiny village at the bottom of the Viant Dam, one of the tallest in the world. With a deafening roar, the wave overtopped the edge of the dam, taking out everything in its way. The 1980 mega-tsunami in the USA was also caused by a landslide. The upper 1,500 feet of Mount St. Helens collapsed after a volcanic eruption. A part of this avalanche plunged into Spirit Lake. It pushed the lake waters into a series of waves almost as tall as the Eiffel Tower. Volcanic eruptions are responsible for 5% of the world's tsunamis. For example, a terrifying tsunami that occurred in 1883 was caused by the Krakatoa volcano going off in the Sunda Strait. The eruption nearly emptied the magma crater under the volcano. The overlying seabed and land collapsed into it. This created several tsunami waves that rose higher than 130 feet above sea level. Some tsunamis are caused by meteorites crashing into our planet. That's what happened millions of years ago when an asteroid struck the Yucatan Peninsula. Yep, the same one that's thought to have wiped out the dinosaurs. It generated a mega-tsunami, the largest in Earth's history. The first wave was almost twice as big as the world's tallest building, the Burj Khalifa. But most tsunamis, about 80% of them, get born in the Pacific Ocean's Ring of Fire. Why? Well, this region got its name for a reason. It witnesses tons of volcanic eruptions. The Portuguese navigator and explorer Ferdinand Magellan visited the world's largest ocean at the beginning of the 16th century. He found the waters surprisingly calm. That's why the place was called the Pacific, peaceful ocean. Little did the traveler know that it was home to the Ring of Fire. It's a 25,000-mile-long horseshoe-shaped chain of volcanoes and other seismically active spots. It starts from the southern tip of South America and goes all the way up to the North American coast and the Aleutian Islands. Then it moves down toward Japan, the Philippines, and Indonesia. After that, the chain curves back into New Guinea, covers the Southwest Pacific Islands, and ends in New Zealand. Right now, the Ring of Fire isn't actually a closed ring, but if you consider Antarctica's dormant volcanoes, you'll get the needed shape. The largest and most active volcanoes on the planet are in this region. They're Mauna Loa and Kilauea in Hawaii, Mount Fuji in Japan, Mount St. Helens in the USA, Krakatoa in Indonesia, and many others. Anyway, the volcanic chain outlines the Pacific Ocean and goes over the meeting points of many tectonic plates. The largest of them are North American, Eurasian, Caribbean, Antarctic, and others. These plates never stop moving. They collide into, slide past, and move below and above each other. This relentless activity makes volcanoes erupt. Deep ocean trenches appear seemingly out of the blue. The 7-mile deep Mariana Trench, the world's deepest part of the ocean, is also in the Ring of Fire. It was formed when one tectonic plate was pushed under another. These days, the Nazca Ocean Plate is being forced down and under the South American continental plate. Unfortunately, the first plate doesn't want to go down smoothly. The process uplifts mountains and sends magma closer to the surface. When energy gets released from the molten core of our planet, tectonic plates move and scrape against each other. Pressure builds up in those areas and then produces earthquakes. Their epicenters are scattered along the areas where the tectonic plates meet. Almost 90% of all the earthquakes in the world happen in the Ring of Fire. The strongest earthquake ever recorded happened in that region. It was 9.5 out of 10 on the Richter scale. The Valdivia earthquake, also called the Great Chilean Earthquake, happened on May 22, 1960. It lasted for almost 10 minutes. The disaster affected an area the size of California. It also caused huge tsunami waves that reached the shores of Hawaii, Japan, the Philippines, Australia, and New Zealand. Experts often describe the Ring of Fire as a coincidence. When natural disasters break out on its opposite sides at the same time, they're never related. For example, in 2016, several earthquakes rocked Kyushu Island in Japan. Soon after that, Chile also experienced a powerful earthquake, 7.2 on the Richter scale. But neither of those quakes set off the other. The distance between the epicenters was around 10,000 miles. This gap was way too large for the disasters to be connected. Anyway, an undersea earthquake makes the ocean floor suddenly rise or fall at the boundary of tectonic plates. This displaces immense volumes of water and launches the waves that soon turn into a tsunami. And since earthquakes happen in the Ring of Fire more often than anywhere else on the planet, this region also sets off lots of tsunamis. By the way, even though the Pacific is the largest ocean on the planet, it might disappear in the next 300 million years. The tectonic plates are drifting, the Atlantic keeps opening, and the Pacific is closing. Incredibly slowly, but still. One day, the Americas may collide with Antarctica, which is drifting northward. After that, Asia and Australia are likely to join this new supercontinent. This process might create a new Pangaea. It was an ancient supercontinent, at those times, the only one on Earth. It started to break apart about 200 million years ago. Some geologists don't support this theory. They believe that the Atlantic or the Arctic oceans are more likely to disappear than the Pacific.
On a sunny day, a man was diving in shallow waters near South Africa. At one point, he saw something that didn't catch his eye at first. A pile of shells that looked as if it had been put together. Maybe by some other diver, he must have told himself. But out of all these shells came the most unusual of creatures, an octopus. The gorgeous underwater animal looked straight at the man before swimming away. Impressed by his new acquaintance, the diver started visiting the octopus every day. He watched it use shells and seaweed to protect itself and learned how it hunted and cared for its eggs. All these encounters became the basis for a now famous documentary. In the movie, the diver wanted to study the relationship between a wild octopus and its observer. Initially, the octopus was a bit too shy to let the man get close. But over time, it began to trust him and even explored his body. At one point, the octopus even rested on the diver's chest. The man soon began to look at the underwater creature as his octopus friend. Sure, the documentary did make it look like a true friendship, but that was most likely because of all the close-ups and eerie music. But you can't really know what the octopus is thinking. Maybe what looks like tenderness is just curiosity or confusion. Maybe an apparent hug is really just a defense mechanism. Some people may love octopuses, but can they really be friends with a human? Until they learn to talk, I guess we'll never know. That doesn't make an octopus less of an interesting creature, though. Apart from those quirky sets of tentacles, obviously, octopuses have another characteristic that sets them apart from other sea creatures. A recent study that involved studying the footage of octopuses living underwater shows that they sometimes develop this unusual behavior. They seem to throw things at each other on purpose. It can be anything from dirt from the bottom of the sea to shells or rocks. Octopuses are known to be solitary creatures, so when something or someone, like an underwater camera person, gets too close to them, they might lash out. Just as we have yet to discover the limits of our galaxies and constellations, we know very little about the bottom of the sea. It's one of the reasons why we find it so hard to explain the behavior of some underwater creatures. The truth is, we don't have good enough technology able to deal with harsh conditions and a limited amount of light underwater. You might have asked yourself at one point, what's the deepest part of the ocean? It's called the Mariana Trench. We don't really know exactly how deep this giant hole is, since it's too difficult to measure, but it's somewhere around 6.8 miles deep and 5 times longer than the Grand Canyon. This massive underwater trench was first studied back in 1875 with the help of a weighted rope. Back in 2012, a Canadian film director reached the bottom of the trench in a submersible vessel called the Deep Sea Challenger. Some of the most bizarre creatures on the planet were discovered here, including the Dumbo octopus, the sea cucumber, and the goblin shark. The Mariana Trench got its name from the nearby Mariana Islands, which were named Las Marianas in honor of Spanish Queen Mariana of Austria. The Mariana Trench might be the deepest part of the ocean that we know of. But one other mysterious phenomenon that's interesting for researchers is called phantom bottoms. In the late 1940s, when the sonar became standard equipment, ships and submarines noticed unexpected signals coming from the ocean. Those signals came from areas where no seafloor was supposed to exist. What's even more mysterious is that this fake seafloor appeared to move. One researcher at Scripps University found out that these phantom bottoms showing on maps were indeed alive. They were made out of a layer of jellyfish, shrimps, and other deep-sea creatures. The reason why they move is that they rise to the surface at night to feed. To top it all off, even the way these creatures move is kinda calculated. They don't just move randomly, but seem to gather together by species. We used to believe underwater animals behave this way only to avoid being caught by predators. It's a mystery to scientists why they group in the same way to form a fake seabed. Our curiosity about the deep waters doesn't stop at the seafloor. If you went on a vacation to the beach when you were young, you probably remember the fun of digging in the sand. As the hole got deeper, you may have asked yourself, could I dig all the way to the other side of the earth? None of us have ever found out. Our parents took us home when it got dark and chilly. Scientists are more reasonable when it comes to this subject. For starters, they know the best place to start digging would be underwater, since those regions are already deeper than what we can find on land. They also do not have the ambition to drill a tunnel through Earth. It's not even possible. That's mostly because of the extreme heat and pressure inside our planet. Even if we could technically dig a tunnel, it would not be safe to travel through it. However, reaching the mantle and retrieving a sample would be a huge scientific achievement, similar to landing on the moon. What we live on is called Earth's crust. Underneath it, there are other layers called the mantle, outer core, and inner core. Researchers have been trying to drill into Earth's mantle since the 1960s, but they haven't succeeded. Some failed due to technical issues, and others were unlucky and chose the wrong places to drill. Our planet's mantle is made of molten rock. Wouldn't that be dangerous if we ever reached it? Scientists say we have nothing to worry about, though. If and when the drillers eventually pierce through the crust underwater, hot molten rock won't pop up the hole and spill onto the seafloor like it would during a volcanic eruption. Mantle rocks aren't solid, sure, but they move slowly, at the same speed as your fingernails grow. Another of those famous deep-sea mysteries is that of the 1997 bloop. You heard that right. I'm talking about a weird sound that seemed to come from deep under the waves. People heard it in the South Pacific. No one had ever recounted a sound like that before. Some thought it must have been emitted by a strange creature living deep in the ocean. It didn't help that the noise came from a location mentioned in a story by famous writer H.P. Lovecraft. In his story, it was a creature called Cthulhu that lived there. In the novel, the author described it as a large, human-like monster with tentacles on its face and wings on its back. For many years, people tried to figure out where the noise came from. It wasn't until 2005 that they concluded it was from icebergs breaking off of glaciers. Some people still don't believe that this explanation truly makes sense and are searching for a different reason for the bloop. If creatures living outside of our planet ever decided to come to visit, you wouldn't expect them to go straight to the bottom of the sea, right? Well, some people claim there's a sort of spaceship on the ocean floor, discovered in 2011. It's basically an oval-shaped object located on the bottom of the Baltic Sea. In 2012, a team of divers explored the anomaly and found what appeared to be a staircase and other structures on its surface. This only added to the belief that the large object had been made by someone and wasn't just a natural phenomenon. Even more bizarre, close to the unidentified anomaly, the explorers' electrical equipment, like sonar instruments and satellite phones, started to malfunction. Some scientists believe it just to be a glacial deposit or some other natural formation, but they still don't know for sure what it is.
The Earth has three main layers: two parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon, and made of nickel and solid iron. It's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which in turn protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Canary Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.
Oh wow, there's a hole in the bottom of the ocean. It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia. A road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space, too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found. Hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn.
Now, have you ever wondered about the longest time it rained nonstop? Even an hour of rain could be a big deal if you're hanging out in a dry spot like the Atacama Desert in South America. It can set a record for that place. But in super rainy spots like the Amazon rainforest, having 40 days of rain in a row might not even turn heads. Interestingly, we only have rainfall records where people live and keep track. Many towns and cities skip the whole rain data collection thing. Plus, there are so many places on Earth where nobody lives, like rainforests or the open ocean, so our rainfall knowledge is a bit patchy. Now, if we were to talk about records, Hawaii has a couple. People there have some seriously long rainy days, especially on islands where winds come from the mountains. From 1939 to 40, they recorded 331 days in a row with measurable rainfall. If you're a person who likes to watch the rain at home with a cup of tea, this might sound ideal to you. But we need to see the sun at least occasionally. Getting some sun is good for your body and soul. Obviously, you get vitamin D. Just 5 to 15 minutes of sunlight a few times a week can make a real difference. And have you ever heard the phrase sunny disposition? Researchers found that people feel down when there's not much sun around. Sunny days make us happier. Sunshine boosts your serotonin, which fights off bad moods. That sunny serotonin isn't just for your mood, it also helps you sleep. And it's also a heart assistant. When the sun hits your skin, your body releases something called nitric oxide, which chills out your blood pressure. Healthy blood pressure means a healthier heart. Now, go tell that to the people who had to go through 881 consecutive days of rain. Yeah, the record was set almost 3 full years of rain. This happened from 1913 to 1916 in Hononumomaki, Hawaii. It rained like there was no tomorrow because the region is a tropical rainforest. How do clouds make rain? Well, rain happens when damp air goes up into the sky and gets a bit chilly. As this air cools down, tiny water vapor molecules huddle up, forming super small droplets that look like a fluffy cloud team. Now, inside these clouds, things get playful. The air moving around can sometimes make these droplets bump into one another and get bigger. Then they can turn into ice crystals high up in the clouds where it's chilly. These little ice buddies get heavy enough to take a tumble down, melting in the rain on the way to the ground. Now, there isn't just one type of rain. Raindrops can come from all kinds of storms. Thunderstorms show up, make a splash, and then they're out. They can dump a ton of rain in no time. Other storms, like winter storms, are more laid back. They stick around for days and dish out gentle rain or even snow if it's cold enough. Usually, the weather switches between moods. It's nature's way of balancing things out. After stormy weather, the sun comes out, the air dries up, and we get to enjoy some clear skies. But things can get interesting if you're in a place with mountains near the ocean. When moist air hits the mountains, it's forced to climb over them, creating rainfall lasting sometimes for weeks. What if I told you there was a time on Earth when rain fell continuously for 2 million years and completely reshaped the planet's destiny? At the end of the Permian era, around 234 million years ago, I wasn't around then, but I read about it, the Triassic period began, marked by the onset of an extended period of rainfall. This phenomenon is now called the Carnian pluvial event. Well, that's what they decided to call it. Recent studies, supported by evidence, suggest that it didn't reshape the planet in that sense, and that it was triggered by coal combustion. The rain wasn't continuous either. So we just debunked a myth here. Woohoo! Next, we have columnar jointing. This is the fancy term for groove patterns that form in lava flows, sills, dikes, and other rocky stuff. These lava creations come in all shapes and sizes. Most are seen as straight, parallel columns. Some have curves and varying widths. They can be as high as 1,181 inches. I'll save you the math. It's roughly 98 feet. The columns are formed by pressure and the cooling process. As lava becomes cooler, it shrinks and forms cracks. Once a crack starts, the lava moves around. These cracks expand to the surface of the flow. Water sneaks into the cooling lava, making it chill down fast starting from the surface, leaving its mark in those patterns. Devil's Postpile in California is a must-visit place if you want to see columnar jointing. But hey, they're found all around the world. Let's raise our heads to the sky to see something magical. Fire rainbows, also known as circumhorizontal arcs, look like flames dancing above the clouds. To see these eye-catching arcs, you need a special cloud type called cirrus clouds and the sun at least 58 degrees high in the sky. It's a VIP collaboration between sunlight and clouds. Let's break it down further. Take London, for instance. It's around 51 degrees north. Now, sorry Londoners, no fire rainbows for you. Now we move to deep waters to see underwater crop circles. These are giant circular patterns found in 1995 near the shores of southern Japan. Locals were baffled. They dubbed them mystery circles, as if the ocean had a secret talent for sand art. The mystery was solved in 2011. The unlikely artist turned out to be a tiny pufferfish, just 5 inches long. The researchers found out that males were on a mission, spending a solid 7 to 9 days building their circles by swimming in and out and using their fins to carve valleys into the sandy floor. They decorate the peaks of their creations with bits of shells and corals, turning their sandy canvases into masterpieces. Okay, they don't do it for the sake of art. The curious circles have a purpose. The sandy center of the circle serves as a nest. Male swimming moves mix things up, getting sand particles just where they need to be. When a lady pufferfish swims by, the male twirls and dances, swirling sand around. If she is impressed and thinks he is the one, she lays her eggs in the sandy heart of the circle. There you go, another happy ending. Now let's look at frost flowers. You might have seen thin sheets of ice that look like delicate petals and sometimes pop up from the stems of plants. The ice is about as thick as a credit card. It forms when the weather is cold outside. The soil is damp but not frozen, as well as plant stems. Not all plants produce these frost flowers, and the conditions must be just right. Here's how it happens. The water inside a plant stem gets pulled up from the ground. When it freezes, it expands and cracks the stem vertically. As it hits the chilly air, it turns into ice. As more water gets pulled up through the crack, it keeps pushing out super thin layers of ice. Whether a frost flower looks like a narrow ribbon or a wider one depends on the length of the crack. And the way it curls and shapes itself into these petals is random, or the reason might lie in the difference in friction along the sides of the crack. These frost flowers are unique and delicate, and they don't last long. They melt or just disappear quickly. To spot them, keep an eye out for tall grass, especially in places that don't get mowed much. Pay attention to purple ironweed, blackberries, and wing stems. A tsunami hitting major cities on or near the Mediterranean Sea and in the northeastern part of the Atlantic Ocean is not a matter of if, but when. It is scary and surreal to think that places like Cannes or Barcelona could suddenly get slammed by a huge wave. But the fact is, European coastlines are in active tectonic areas. Only about 10% of all tsunamis worldwide happen in the Mediterranean, and there have been at least 290 tsunamis in this area since 1600, before Common Era. Despite the relatively low number, this phenomenon has caused numerous devastating disasters throughout Europe's history. Back in 1755, an estimated 8.5 magnitude earthquake, with an epicenter southwest of Cape St. Vincent, triggered a tsunami that destroyed most of Lisbon, the capital of Portugal. About 40 minutes after the earthquake, this massive wave just slammed into the harbor in downtown, racing up the Tagus River. The phenomenon was so fast that several people on horseback had to gallop to higher ground to avoid getting carried away. And this was just the beginning of a nightmare, with 2 more terrifying waves hitting Lisbon right after. A disaster like this is similar to what we see in the Pacific Ocean several times a century, but in the Atlantic, it's very rare. This type of major tsunami is expected to happen every 3 to 5 centuries, but now it could happen tomorrow. Marseille in France, Chupo in Spain, and other cities are on the list of important locations that could be flooded soon, with a roughly 100% chance of being hit by a tsunami in the next 30 years. Statistics show that the wave will probably be more than 3 feet high. I know, it doesn't sound like much, especially since when we think about tsunamis, we imagine terrifyingly tall waves, like the one that hit Lituya Bay in Alaska. In that case, the wave was over 1,700 feet tall. But we must remember that even waves only 19 inches high can be dangerous to swimmers. Because it's not the height of the tsunami that matters, but also the flow and movement of the water. Not to mention the flooding, which can damage beaches, harbors, and streets. If the coastline has a small harbor and the waterfront is exceptionally low, like Cannes, this natural disaster might be much more dangerous. Tsunamis around 6 feet high can lift cars off the ground, while smaller waves can create walls of water traveling at 40 miles per hour. Plus, there are these smaller events that might not wreck everything, but still can cost a ton of money. For example, large sandbars that move around on the ocean floor, like sand dunes shifting in deserts. They can mess up pipelines or deep-sea cables for internet and communications, and that ends up costing businesses and governments millions of dollars. That's why organizations like UNESCO are worried about the possibility of a dangerous tsunami hitting Europe soon. So they're doing everything they can to prevent apocalyptic scenarios, like what happened in 2004 when an earthquake off the coast of Sumatra, Indonesia, caused waves over 100 feet high in coastal communities, resulting in over 200,000 lives lost. And let's not forget about 2011, when an earthquake off the coast of Tohoku, Japan, triggered a tsunami that reached about 6 miles inland and caused a major nuclear accident at a power station along the coast. Over 16,000 people lost their lives in that tragedy, and the event resulted in billions of dollars in infrastructure damage. These disasters were huge wake-up calls, and we've come a long way since 2004. We're much safer today, largely because the tsunami warning system is highly effective at quickly detecting this dangerous situation. Unlike many other natural phenomena, a tsunami can be anticipated. We may only have a few minutes to act, but if we all know what to do, many lives can be saved. And in most parts of the world, sirens are commonly used to alert people to tsunamis. To sound the siren as early as possible, initial tsunami alerts usually rely only on seismic data. First, specialists receive information about an earthquake. Seismic waves travel about 100 times faster than tsunamis, so they have enough time to analyze the data and see if the earthquake might have generated a tsunami and whether they should issue an initial tsunami alert. At U.S. warning centers, for example, scientists typically issue initial alerts within 5 minutes of an earthquake. If a tsunami is suspected, these alerts may also include information about wave arrival times, recommended actions, and potential impacts. But sounding the alarm is not enough. To save lives, coastal communities also need to be trained to respond fast and in the best way possible. That's why UNESCO produced this program called Tsunami Ready, aiming to train people living in coastal areas at risk on how to act in case of a tsunami event by the year 2030. The idea is to help communities stay safe by teaching them how to protect their livelihoods and safeguard their homes. Being recognized as Tsunami Ready by UNESCO doesn't mean a community is tsunami-proof, of course. It's more like a recognition that they have adopted all possible measures to mitigate tsunami risks. So authorities are helping communities to prepare themselves by installing evacuation signs, establishing security procedures, and creating plans to warn tourists. Like Spain, which distributed tsunami warning signs along the entire coastline, as well as signs showing evacuation routes to higher ground. And Spain better be prepared. I mean, only 7 tsunamis have hit the country since the year 365, so it's difficult to predict the effects of such an event. But they could be devastating, considering that Spanish coastal areas are so economically important. There's also a danger zone in the Averroes Fault, beneath the Barents Sea. If an earthquake happens at this point, people will have only 21 minutes to escape a tsunami. UNESCO has also established 12 tsunami warning centers, which cover Europe as well. This initiative involves 5 centers located in the Mediterranean and Northeast Atlantic regions. These centers can save thousands of lives because they monitor ocean disturbances 24/7. Then, after analyzing the threat, they send out messages based on the event's potential to cause a tsunami. The intensity scale ranges from no effect to completely devastating. And by that, they understand that nearly all brick buildings could be demolished by waves, and even the most reinforced concrete structures could suffer heavy damage. Now, so far, we have mostly talked about tsunamis caused by earthquakes along converging tectonic plate boundaries. In fact, earthquakes have accounted for over 80% of tsunamis since 1900. But tsunamis can also result from landslides, volcanic eruptions, and even meteorite impacts. Experts are also worried that with the current changes in climate, we might see more of mega-tsunamis popping up in the Mediterranean. These ones are triggered by freaky weather conditions and can mess with any coastline that's got a shallow seafloor. They might not be as huge or famous as the earthquakes ones, but they can still cause significant property damage and put people in danger. For instance, in 2006, a mega-tsunami struck the harbor of Ciutadella on the Spanish island of Menorca. Yachts were tossed into each other and later stranded on the harbor floor as the water receded, resulting in tens of millions of euros in damage. Unfortunately, mega-tsunamis in the Mediterranean tend to be stronger during summer, so if you're planning to spend your vacation in Europe, stay alert for any signs of dangerous waves. If you suddenly encounter a tsunami moving in your direction, remember this is the time to react. Move to higher ground as far inland as possible. Pay special attention to any emergency alerts and information, and follow the guidance of local authorities. Most importantly, do not wait around taking photos. Leave the area as soon as you notice any signs of this danger event, or if you hear an official tsunami warning. Hey, stay safe.
Going to the beach in winter seems like a good plan. You can have a bonfire, build a sandcastle, search for shells, or swim in the ocean. The vibe might make you overlook the dangers ahead of you. Do you really think through the potential risks of paying a visit to the beach in the winter? The number one risk is waves. You might think it's okay to admire the view on the beach a few steps back from the ocean. Now let me introduce you to sneakers. Not the chocolate bar, sneaker, or with another name, sleeper waves. These are oversized coastal waves. They catch people off guard because they occur without warning or trace. These waves are particularly seen in Oregon, United States. People have been injured and at least 17 people have been swept up into the ocean since 2000. It got more media attention in 2011 when a memorial statue was built honoring the two teens faced with sneaker waves in Oregon. So, how come these waves are so dangerous? It's about their nature. They come out of the blue. With big waves, you see them coming or growing big. Plus, they form in the ocean and come towards the beach. These waves appear near the shore. It leaves less time for you to run to a safer spot. Okay, most of the time, they're not huge, as would be seen in apocalyptic movies. Yet, you can never know what nature holds. Maybe you remember this example from Mavericks. In 2010, a crowd was watching the surfing competition. Suddenly, two large waves struck the people on the beach. It broke the seawall and injured more than 10 people. Sneaker waves don't look particularly larger than other waves until they break and quickly reach the beach. They form in a period of 10 to 20 minutes in between soft and regular-sized waves. They can surge more than 150 feet beyond the foam line. Then they reach the land with high power. Plus, they carry lots of sand and gravel with them. Sleeper waves are more commonly seen along steep coastlines compared to beaches with wider and softly sloped areas. People named these waves, not scientists. They observed what waves do. They washed up in a sneaky way. I mean, scientists didn't classify this phenomenon as a distinct sort of wave like they did with tsunamis or rogue waves. There's little scientific research made about them. Researchers say that sneaker waves form in offshore storms. These storms transfer the wind energy to the water surface. The waves carry this energy and then arrive at the beach during times of calm weather. The larger amount of energy they obtain compared to the regular waves that preceded them causes them to go higher up the coast. Imagine you go for a walk on the beach with your dog. The waves gently reach the beach. You play the throw and catch game. You don't know about sneaky waves, so you turn into an unwary beachgoer. What's the risk? Being washed into the water trapped against rocks. Since it's winter, you tend to wear heavier clothes. The sand that sneaker waves carry can quickly fill clothing and shoes, and that weighs you down. How can people enjoy the beach safely? First off, keep your distance if you're on the beach for storm watching, for instance. It might be mesmerizing to see how waves roll in over miles of ocean. The storms hit the shore, and you look at those extreme turbulent swells transform into strong 30-foot-long waves. Finding a higher spot that sees the ocean and waves might be best. Be the eagle, not the crab. Did Confucius say that? The second tip is if you're determined to storm watch, never turn your back to the ocean. Yes, eyes on the water. Lastly, be mindful of which part of the beach you're walking on. Stay away from the logs because they hold water. The water increases their weight. In the worst-case scenario, the ocean is powerful enough to roll the logs onto you. Let's assume you're hiking near the ocean. Use the designated trails because park authorities determine them as the safest roads possible. Going off-route can sound charming, but it can be dangerous for you and harmful to the ecosystem in the surrounding area. Now that you know where to walk, you can keep your eyes open about the geological stuff. Like the rocks can be slippery, erosion can rip them off. Yeah, it's better to avoid walking near bases of cliffs and bluffs. You'll never know when a natural phenomenon will occur. It might sound a little extreme, but you may want to check the tsunami evacuation routes of the area you're visiting. Tsunamis are hard to predict, but tides aren't. Tide tables are available online. This natural phenomenon looks harmless, yet it can isolate rocks from headlands and the shore. You probably don't want to find yourself with soaked wet clothes in the ocean for no reason. Climbing up onto the logs might not be the best idea either. Sure, they look heavy and sturdy when you're climbing, but even the smallest wave can take you like a leaf flying in the air. Not just logs, but also jetties are tricky. Sudden waves can make you lose your balance, and you can collapse. Let's return to the scenario where you and your dog are walking on the beach. This time your pet sees shorebirds and chases them. Birds could be there for foraging or roosting. Your dog could interrupt their chill zone. They can lose their energy reserves. Can you bump into creatures hiding under the sand? Some sorts of creatures can be dangerous for you. Better not to poke someone's home. Take a look at this one. It's a horseshoe crab. This one looks scary, yeah, but it's safe as long as you don't step on its spines. So it depends on the type of creature you see, but generally, it's okay to explore the sand with caution. Until now, we look at scenarios where you were on the beach when they caught up to sneaker waves. You could be in the water too. You could be surfing, just like the contestant in the Mavericks surf competition, or swimming, if swimming is the new case. Consider these. The temperature is lower, the waves are crazier, and there are probably no lifeguards there watching you in the winter. Swimming with friends is a safe option. Bonus, it's more fun. You should choose your swimming location carefully. Are there dangerous rocky areas? Can you easily go out if there's some sort of emergency? Know your spot. For that, you should check the weather too. Planning has a key role in winter water safety. A quick weather forecast and sea conditions check would do. You can consider buying a tow float if you're an adventurous open water swimmer. It's a flotation device designed to increase the swimmer's visibility in the water. They are lightweight and have fluorescent colors. Alternatively, you can wear a brightly colored swimming cap. We can talk more about the gear. Wearing a wetsuit is wise, as well as wetsuit gloves and boots. You can put your phone in a waterproof pouch or bag. Staying warm is essential in the winter. Don't just jump into the water at once. This can result in cold water shock. It's vital to enter the water slowly. In that way, your body can get used to the temperature. Once you take all the necessary precautions, you can enjoy the beach and explore its offers. What sort of gems can you find on the beach? A mermaid's purse? Maybe. No, it's not the purse of Ariel from Disney's Little Mermaid. That's actually an egg case belonging to sharks and rays. It's made out of keratin, kinda similar to your hair and fingernails. These purses are the place where the embryo grows. The egg hatches and the cases are carried away with the water to the beach. If you want to find one, you can look at the area near the seaweed. Have fun while searching for it! Now, I'm ending this video with a quick joke that's suitable for the cold weather of winter. What did the ocean say to the beach? Nothing. It just waved. A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of -15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega-earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long, and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe.
In November 2020, a wave the height of a 4-story building was recorded off the coast of Vancouver Island, Canada. The team at Marine Labs, the company that operates the buoy that got caught in it, couldn't believe the data they saw. Everything was normal, then, unexpectedly, a vast force came, pulled the buoy down, and then sent it up to a peak before taking it even deeper. The probability for such a huge wave to form is once in 1,300 years, so they had to be sure it wasn't a technical mistake. Marine Labs sent the data to a rogue wave scientist at the University of Vancouver. They analyzed and validated the findings and shared them in February 2022. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Luckily, this giant didn't leave any damage, as it happened too far offshore. For centuries, rogue waves were believed to be real only in the stories of sailors. Christopher Columbus himself mentioned a rogue wave, but back then, it wasn't officially a thing. In August 1498, he was on his 3rd expedition to the Americas. As they were passing through a strait near Trinidad, a huge wave lifted the boats. They managed to survive and continue the journey, and the area is still known as the Mouths of the Dragon, named this way by Columbus. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got caught in a terrible storm and witnessed several waves over 80 feet tall. One of them was the height of a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and spread the story of the gigantic waves. But back then, scientists were sure waves couldn't be taller than 30 feet. So everyone took this story as a tale. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This sea monster of the North Sea hit the Norwegian gas platform Draupner on New Year's Day. It reached a height of 84 feet. The waves surrounding it were twice as small. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. It became a sensation in the scientific world because it wasn't like any other type of wave they'd studied before. So they gave rogue waves an official definition. It's a wave more than twice as tall as others around it. These bad boys, also known as freak waves, monster waves, and episodic waves, can pop up lightning fast in a stormy sea or show up out of nowhere in calm waters. They have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters just trying to do their job. Rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. Scientists and sailors singled out some statistics. Rogue waves more often form when wave trains run into fast ocean currents. The coast of South Africa is one good place for that. There are concerns that these water beasts may happen more often in the future because there's more energy in the atmosphere and ocean. It means larger and more frequent rogue waves and more ships lost at sea. Rogue waves aren't limited to oceans and can even occur in lakes. Lake Superior witnesses something that got the name Three Sisters. It's a series of three large waves, one after another. The second wave covers the ship decks before the first one is gone. The third wave jumps in and adds extra water. These three sisters overload the ship. There's a theory that this phenomenon took down the steamship Edmund Fitzgerald in 1975. Rogue waves are also dangerous because they form rogue holes in the water. When the wave builds up, it draws in all the water around it. So, near the base, these holes can be very deep. If the bow or stern of a ship ends up in one, the ship can instantly sink. Some oceanographers believe that rogue waves are to blame for the disappearance of ships in the notorious Bermuda Triangle in the Atlantic Ocean. Storms from several directions converge in this mysterious area, so rogue waves are more likely to gain force here. And because they can reach a height of 100 feet, they can theoretically bring down an airplane, not just ships. There are two main theories trying to make sense of how rogue waves happen. First up, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. Now, when these waves cross paths, they team up and become stronger, cooking up a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they share some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and toss it into a fancy math model that paints a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but as scientists measure more rogue waves, mathematicians may find a way to alert us of the upcoming rogue waves rising out of the water. Sometimes you can hear the term sneaker wave as a synonym for rogue waves, but oceanographers claim there's a difference. Rogue waves occur mostly in the ocean, and sneaker waves build up at the shore. They're also known as king waves and sleeper waves, and they roll up much faster than usual waves when they approach the beach. They always appear without warning after smaller waves and can be powerful. They can carry swimmers further away into the ocean. But the worst part is, they can also sweep you off your feet and into the water when you're casually strolling on a jetty or the beach, or on an outcropping nearby. Oregon State University researchers found that sneaker waves form in offshore storms that carry wind energy to the ocean surface. With all that energy, several waves unite and overlap into one beast that stands higher and goes further ashore than a regular wave. Another thing that makes them more dangerous is that, just like rogue waves, they're hard to predict. Fishers, surfers, and others who spend a lot of time by the water normally know when and what to escape when it comes to big waves. With sneaker waves, that logic doesn't work. There is no set time of the year when they're more active either, but putting together some data shows you're more likely to experience one of those somewhere between April and October, and the peak would be in October and November. Sneaker waves carry huge amounts of water, sand, and gravel. Those can fill up your shoes in a matter of seconds and sweep you off your feet if you're unlucky enough to be ashore at that moment. These sea monsters